from 2005 to 2008, you want to know, was there a point, did we have a maximum, will we have a maximum? If we have an equation then that goes with that profit information, is it possible for us to have a maximum using this profit function that we know is adequate for our business here? Is there going to be a point where we have a maximum? How many years down the road is it going to be before we'll see a maximum? If you can extrapolate the data using the formula that you designed, and take the derivative, and you know that you're going to say, well, let's just say that our profit is going to be the same. It's going to be, is it going to be flat, or is it going to go up, or is it going to go down? We can look at that and determine answers like that. Okay, well, let's see what else we've got here. Graph the function. We got 4x equals, 4x minus tangent pi x on the interval from -1/4 to 1/4. Determine whether Rolle's theorem can be applied to the function on the interval and find all values of input in that open interval such that the derivative is equal to 0. Now, what I could have said is, determine whether Rolle's theorem can be applied and find all values of c that guarantee it, and just leave off this piece, because that kind of gives you too much if you know Rolle's theorem. But go ahead. We're going to... Okay, so the window, -1/2 to 1/2 every quarter unit being measured off. Output -5 to 5 every unit. And we come up with this. The first thing said was to graph that. Okay, now determine whether Rolle's theorem can be applied. Well, is Rolle's theorem continuous would be the first thing we have to talk about. So, is f of x continuous? My spelling here. Now with tangent, let's see, I need to be concerned with that tangent, don't I? What makes cosine undefined? Well, I'm sorry, what makes tangent undefined? When cosine is 0, and it's 0 here, and it's here, this is pi divided by 2 and 3 pi divided by 2. If I'm at -1/4 and 1/4, let's see, x is -1/4, so that would be negative pi divided by 4. If I make x be 1/4, -1/4, negative pi divided by 4 is going to be somewhere in here, right? Terminal side. And pi divided by 4 is going to be somewhere in here. So is is tangent in jeopardy of being undefined at those? No. Okay. So I think we're safe on that. So the answer would be, is it continuous? The answer would be yes. Is it differentiable? In the open interval from -1/4 to 1/4. Well, any problem finding the derivative of 4x? No. Any problem finding the derivative of tangent? If tangent is defined, then we'd be able to find its derivative, so we're okay there. Okay, so we'll say yes on that. So now the next thing then is to take the derivative. So we'd have 4 minus, and if we look at the derivative of tangent, let's see, we've got negative secant squared pi x. Let me break that out. I don't want to just do that in that way for you. I think we need to talk about it here. If we don't get to the next theorem, that's okay. Come on, there we go. If we're looking at this, we've got now a composite function in here, tangent pi x, and so we need to treat it as a composite function. So I need the derivative with respect to x of tangent pi x, and then multiply that times the derivative with respect to x of pi x. So this is the outside function, and this would be the inside function. So what is the derivative of tangent pi x? And according to my notes, negative secant squared pi x. Could you do that without using secant? Sine divided by cosine, go through that whole thing again. Okay, the derivative of pi x divided by, the derivative of pi x with respect to x would just simply be pi. And make sure that I'm not racing here, trying to get through this last problem. Yes, Casey, what do you have there?
Why is it negative secant squared?
Yeah, I was just kind of asking myself that same question. Let's go through it. I'd feel much better if we go through this and look at tangent pi x. We'll make that g of x so we don't confuse it. And we'll make that sine pi x divided by cosine pi x. So now the derivative of that would be our denominator times the derivative of our numerator, which would be cosine pi x. I know I'm not writing that line out. Minus, what is it, the numerator times the negative. Derivative of cosine is negative sine x. This is what happens when I try to hurry. Cosine squared pi x. Let's see here. I've got cosine squared pi x plus sine squared pi x divided by cosine squared pi x. Are you guys doing this with me? Make sure I don't have an error here. This should be negative sine pi x here. That's how I'm getting positive. Yeah, how do we get a negative on that? Yeah, and that's what I'm getting here. In my notes, I've got it looked like I had a negative. I probably did something I shouldn't have there. So because this would be equal to 1 divided by cosine squared pi x. If you know cosine squared plus sine squared is 1. So yeah, I'm going to take this negative away. I wasn't quite sure about that either. Okay, are we agreeing now? Question is, number 4 is to set the derivative equal to 0. So we have 0 equals 4 minus pi secant squared pi x. Now what are you going to do? Now what are we going to do? Well, let's see. I could make 4 equals pi secant squared pi x. Well, but then I have the negative here, so I kind of took care of them together. But yeah, you would have negative. 4 divided by pi is secant squared pi x. Plus or minus the square root of 4 divided by pi is equal to secant pi x. What are we trying to solve for? X, good. I mean, we can get so lost in these problems. I'd rather work with cosine and sine, and let's see. This could be plus or minus 2 divided by the square root of pi equals 1 divided by cosine pi x. I'm going to, let's see, if we drop the plus or minus, that's kind of chancy to do yet. What if I multiply both sides by cosine pi x and multiply both sides by square root of pi and then divide both sides by 2? Can you visualize that without me putting all those steps down? Multiply both sides by cosine pi x, I'd have 2 cosine pi x equals, okay, so let's say this, we'll just put it in smaller steps here, equals square root of pi. Okay, so I just what we usually call cross multiplication. Okay, so then I could say cosine pi x equals plus or minus the square root of pi divided by 2. Yeah, we won't get to the next theorem, but that's okay. We'll finish this one up, and then we'll go. Shoot, this is where we really have to think about what do we have when we have a trig function? What is the input of all trig functions? Angle measure, yes. Okay, so the angle measure, some multiple of pi there. Pi, 2 pi, 3 pi, and so forth. What is the output ratio, okay, of two sides of a triangle, right triangle? Okay, so now I've got to get inside the input here. So in all of mathematics, if you want to get inside the input, you have to use the inverse function. Okay, inverse function. So we'll use the inverse function of cosine, which is known as arc cosine. Now, if I use the inverse function of this, you know, if when I have a square root, I take the square. If I have, you know, what are some of the others we commonly do? But anyway, what I do is I have to use the reverse of that. So when I do the arc cosine, it's the arc cosine of what? And I'll go back to what you know about inverse functions. What happens to the inputs and outputs when you do an inverse function? They switch. So now this is going to be the arc cosine of plus or minus the square root of pi divided by 2, the ratio. And we're going to come up with angle measure. Okay, now can we solve for x? It's there. It's all right there. Yeah. Go a long way around to get it, but we're going to have the arc cosine of plus or minus the square root of pi divided by 2 divided by pi, and that should be our answer. Now, how do we get into that answer? Let's do it this way. Up here where I had plus or minus 2 cosine pi x equals the square root of x, I took the plus or minus with the 2. If I don't take the plus or minus with the 2 up here, then I could say that it's plus or minus cosine. What I'm trying to do then is to take that out of here and place it on here instead, so that it makes it a little easier. I'm just finding the arc cosine then. It's just a matter of assigning that. Okay, very carefully in your inspires we can do this. I'm going to stop this though, and we won't have the rest of this on video.